As promised in part 2 of this series, I am in the process of trying to learn how to use the various software and other options of the Rigol and Siglent. What I've done is I have saved waveforms from these two Rigol oscilloscopes. It's the same waveform, but I have deliberately changed the time base on one so you can physically note the difference. At the top is the 1000Z, and I've saved that waveform as new file 1000, and then down on the 4000 I have saved that waveform, which you'll notice is at a slightly different horizontal scale, as waveform 4000, new file 4000, the purpose of which is I would like to be able to transfer one or more of those waveforms to the Rigol DG1022, which is over there. It's been sitting long enough that the screensaver has kicked in, but nonetheless it is able to read waveforms. But one of the things that I've discovered is that there really does not seem to be any way to transfer waveform data between Rigol instruments except in a few very limited circumstances. What I think is occurring is this. When I try to transfer, and in a minute I'll show you, waveforms from either of these Rigol oscilloscopes to this Rigol generator, what I get is a very, very noisy and corrupted waveform. However, when I try to reload that same waveform into the oscilloscope on which it was recorded, that works okay. So in other words, you can record a waveform on the 1000Z and then recall it to the 1000Z. But if you try to recall that waveform on the 4000, it's corrupted. And if you try to recall that waveform over to the Rigol generator, it's also corrupted. Similarly, a waveform saved on the 4000 will only work on the 4000, and so on. Now, in a little bit, I'll show you what happens when you try to load any of those waveforms into UltraWave, which is the software that came with this DG1022. And once again, you'll see that you wind up with corrupted files. So the bottom line is these features, that is the ability to save waveforms, are very crippled on Rigol instruments. They only work on instruments that are part of the same family. It's as though Rigol is not one company, but rather is a bunch of single companies for each product line. So a product line has their format. The people right next door producing a different product appear to have a completely different format, and so on. I think you'll see as you go along that this whole process can get very frustrating, and I've spent days trying to figure out if there's anything I'm doing wrong. Like one of the things that I considered was that perhaps the memory stick that I'm using, which is right there, is either too new or not new enough. So I've used a variety of memory sticks, everything from a 7 or 8 year old 2 gigabyte memory stick, real slow USB 2, up to this one, which is a USB 3, I think it's 32 gigabyte memory stick. Anyway, it's not the memory stick, it's the Rigol instruments. They just, each one has basically its own proprietary, and by that I don't mean Rigol proprietary, I mean specific Rigol product proprietary. So in other words, it's as though Rigol treats a separate product line as a rival, and in some way sort of protects itself against someone using the rival's product, even though that's another Rigol oscilloscope. I know it sounds crazy, but I think as we go along you'll see that it really cripples what you can and can't do with moving waveforms around among all of these instruments. So let's get on with showing what happens when you try to download these waveforms into the DG1022. Okay, now let's try loading that same waveform into the Rigol DG1022, and by that same waveform I mean the one from the 1000Z and the one from the 4000. I am using a procedure that I downloaded from the Rigol website that says loading an arbitrary waveform into a DG1022, and in a little bit I'll show you that this procedure works fine when you create the waveform in the software for the 1022. That's called UltraWave. But let's see what happens when you try to load a waveform from one of the Rigol oscilloscopes. To do that, you press load, and then you have to press stored. There are three options: the built-in, the stored, and the volatile. The volatile is the memory in the Rigol that disappears when you power it off. The built-in are the factory built-in that stay there forever, and the stored are the things that are stored either in the local memory or on the disk. So we're going to go to the disk. Notice it says local. We're going to go to the disk, and it says there are two waveforms. One is the new file 4000, the other is the new file 1000. Let's try loading the new file 4000. Press recall. It thinks it has recalled. Now we'll turn on the output, and then we'll go over and look at what it looks like on the scope. There is what the file looks like on the oscilloscope. Notice that it is completely corrupted. It bears little relationship to the original waveform. So now let's go try the other waveform. We go to load, stored, UDisk, and this time we'll try the one that we downloaded from the 1000. We call that, and it says fail to read file. In other words, it thinks it can read the 4000 file, but it can't even read the 1000 file, even though in the datasheet for the DG1022 it says it works with all of the DS1000 oscilloscopes. What's really going on is, what they mean is, it only works with a subset of the DS1000 oscilloscopes, not with the 1000Z. So I suspect, although I can't verify this, because I don't have one of those scopes, that it will work with the DS1052, for example. I have no idea whether it will work with all of the models. As you know, it's been updated. So basically, the message that I'm giving you is, if you are buying a Rigol generator or a Rigol oscilloscope and you want them to work together, it's sort of catch as catch can. You can't be sure that they will work together, even if it says in the data sheet, or at least implies in the data sheet that they will, like this one does. This one, it says you can do a DS1000, but I can show you by this, we'll recall it again and you'll see the message, that it will not read a DS1000Z file, even though it says it will work with all DS1000s. Okay, so that's trying to transfer from the oscilloscope to the generator. Now let's try to transfer from the oscilloscope to the software for this unit. The first thing we'll do is we'll load up the UltraWave software, and you'll notice under the file menu that it says you can open an analog waveform. To import a waveform, you first have to create a new waveform, a blank waveform, and then you go into the file menu and import from waveform file. Let's try the 1000. You will see it does not load. Let's try the 4000. Once again, it does not load. And it may be that with enough experimentation, you can find, maybe it's because the dots don't line up or whatever. I suspect not, given the fact that the oscilloscopes don't allow you to move waveforms between the two scopes. They don't allow you to move waveforms between either of the scopes and the arbitrary waveform generator. My guess is that the incompatibilities are more than just the number of dots in the waveform. But nonetheless, I thought I would point this out in case somebody wants to try experimenting. I have checked the Rigol website very carefully. I have downloaded and read everything about the DG1022, the DS4000, and the DS1074Z that has to do with waveforms. I have read the UltraWave help file, and I have watched the video that one of the Rigol distributors did on the UltraWave, and none of them have indicated how you might, for example, set the dot value to something other than 4096. One reason that I think that's not what the problem is here is we're going to create a waveform here in a minute that is compatible using UltraWave that we can download to the DG1022. So let's set that up and I'll be right back. The procedure that I'm going to be following to do this is on a document that is on the Rigol website called Building Multi-Segment Waveforms in UltraWave. Give you a little more light on that. You can download this, so I'm going to follow this exactly. Before I do, I thought I might just let you get a look at this where it says right here, seamlessly interconnect with DS1000 series digital oscilloscopes. Obviously that isn't really true. That's for the DG1022. That's the data sheet I was talking about earlier. And now we'll click on first a sine wave. Procedure says that you want 1,000 dots with an amplitude of 2.5, an offset of 0, 1 cycle, and a phase of 0. Well, the phase is 0, number of cycles 1, offset 0. The amplitude is not set yet, so we're going to enter that as 2.5, and the number of dots is already set to 1,000. So we'll click on OK, and you see it has inserted that wave in the waveform editor. Now we're going to add a segment of 1,000 points with a triangle wave, once again at an amplitude of 2.5, and it's already set there. A symmetry of 50%, and you see it does a nice job of joining those two together. Now we're going to add a declining exponential. Once again 1,000 points, 2.5 volts. And then it says you can also add hand-drawn elements and so on. So now what we're going to do is we're going to do the file save as, and we're going to go to, in this case, we're going to do it as an arbitrary waveform, and we're going to call this Ultra. Now let's see if we can load that into the DG1022. I've inserted the memory card into the DG1022, and I have selected Arbitrary. Once again, it's a stored file, and once again it's on the U disk, and it's the Ultra, which is saved in an RDF format. So we're going to recall that. And now we're going to turn on the output. Now let's look on the oscilloscope at what we've got. And I ask your pardon for the unusual angle. I'll move this later. But as you can see, the oscilloscope is displaying the waveform that we generated. In fact, it's doing a very good job of replicating the sine wave followed by the triangle wave followed by the exponential fall. So what all of this shows is that ultra wave is completely compatible with the DG1022. However, you have to create the waveform. You cannot download a waveform into ultra wave from either of these two oscilloscopes. At least I have not been able to find a way to do that. When you do download, as you saw in the one case where it did allow you to try to download the 4000 waveform, it corrupts it. So that is the extent of my looking at how you can move waveforms among these different Rigol instruments. A little later segment I'm going to be doing the same thing with Siglent. But for right now, I think you can conclude by saying if you are willing to do all of your arbitrary waveform work using ultra wave and the DG1022, it appears to be a pretty good system. I would give it probably a 7 or 8 out of 10. But in terms of being able to move waveforms from oscilloscopes, despite what the data sheet of the DG1022 says, I would give Rigol a 1. A 1 because it looks like they tried, but they failed miserably at doing that. So now let's look at the Siglent and its software and its ability to transfer from the oscilloscope to the arbitrary waveform generator. I've now set up the Siglent oscilloscope and the Siglent generator. The oscilloscope is the SDS1102X, which I previously compared to the Rigol. And what I have on the screen is the same arbitrary waveform that I generated using the Rigol UltraWave software. And you may recall that it consists of a square wave, or a flat portion, followed by a sine wave connected to a triangular wave, and then an exponential fall at the end. What I did was, of course, I had previously uploaded this into the Rigol 1022, so I simply put the signal out there onto the Siglent oscilloscope and then captured the signal off of the Siglent using a CSV file. Then I moved the USB stick down to the Siglent generator and loaded the signal there and turned it on. And as you can see, I had complete success in doing all of that. Now, in a way, it's a little more apples and oranges comparison, because here I'm comparing an oscilloscope and a signal generator, which are relatively contemporaneous. I think this oscilloscope came out 5 or 6, maybe 7 months ago. The signal generator came out 2 or 3 months ago. And so there's less difference in time between these than there were in the Rigol case. But nonetheless, what this shows is that the Siglent X-Series scope and the Siglent X-Series generator work very well together. So let me show you how I did what I have on the screen here, so you can get a little better view of the process, and then we'll go over and see if we can do something interesting using the EasyWave software, which is the Siglent equivalent of the Rigol UltraWave software. I've now got the Siglent oscilloscope connected to the output of the Rigol, with the Rigol outputting this waveform that we generated using UltraWave. What I'm going to do now is move the display, and I'll explain as I go along. What I'm trying to do is to get the waveform to start and stop at the same point. That avoids some discontinuities at the edges that can sometimes confuse arbitrary waveform generators. And this is generally good practice in all cases. It's not something that I have to do with the Siglent that I didn't have to do with the Rigol. You always should do this. The second thing you should always do is stop the oscilloscope before you save anything. So I'm going to do that now. Now I'm going to remove the memory stick from the generator and plug it in to the oscilloscope, and you notice it says USB flash drive detected. Now I'm going to go to the Save Recall menu, and it's asked, do I want to save or recall? I want to save, and the type I have set to CSV. I told you that earlier. And now it says press to save. I do that. Now it comes up with a series of the file names, and it asks, do I want to save on one of these file names or do I want a new file name? I'm going to press new, and it automatically generates a new unique file name. In this case it's SDS and then like 4 zeros and a 3. So I like that one. That's what I'm going to do. So it says press to save, and I'm going to do that. And while this is going, because it takes a little bit to format, I will explain that there's a video on the Siglent website about this process. Okay, now the beep tells you that it has saved that file. So now I'm going to get back out of that. I'm going to remove the USB drive. Then I'm going to go down to the Siglent generator, and I'm going to plug the drive in there. And you see it says it's detected the drive. So now I'm going to recall, and for that you have to use the Store Recall button here. And then it offers to allow you to either recall one of the internals or an external. I want to go to the USB device and browse for the number 3. The 1 and the 2 are previous saves of exactly the same thing, but I want to use the fresh one, the one I just did. And now I press recall, and it says converting, please do not power off. And it now says file input complete. So what we're going to do is move the input for the Rigol, for the Siglent oscilloscope over to this generator, run the generator, turn on the output, and you see we get the same waveform that we had earlier. Now the advantage, of course, of an arbitrary waveform generator is you can adjust the amplitude and the frequency and some other things of the arbitrary wave. For this purpose, I'm not going to do that. I'm just going to illustrate that we have on the Siglent oscilloscope the same waveform we had earlier. And as I pointed out, we're now bringing the output off of the Siglent generator. So that is transfer from an oscilloscope to a generator. Now let's try the software approach, that is using the Easy Wave software, and see how easy that is to use. On the screen is the Easy Wave software, and at the very top you see a small spike. I am going to unzoom the software and you'll see where that spike is. It is right there. This is a 20% square wave with a small spike in it. And I'm now going to download this waveform to the USB stick and then try to transfer it to the Siglent generator. I've now moved the memory stick to the Siglent generator, and at the very bottom there you will see that there is a CSV file named Spike. So I'm going to go down and try to load or recall that file that I generated using the Easy Wave software. And you may notice it says file import failed. I don't know what's wrong at this point, but it certainly is true that I have been unable to import files from Easy Wave. Now, Easy Wave also has a direct connection, that is a direct USB connection from the computer that it runs on to the Siglent generator. I haven't tried that, but what I am going to do is try to recall this CSV file. And you note it does work. This is the one that I loaded from the Siglent oscilloscope. So now let's turn on the generator and see if the oscilloscope can display that wave. Doesn't do a very good job of synchronizing on it, but there it is, and you'll recognize it as the wave that we actually generated using the Rigol software. So in summary, I'm not trying to produce a training video on the software. I'm mainly interested in the connectivity of the different devices at this point. And I will say that I have been unable to download a waveform from the Rigol to the Rigol software from the Rigol oscilloscope. I have also been unable to transfer a waveform from the Rigol oscilloscope to the Rigol generator. Now those are different generations of equipment, and so as I explained earlier, it's probably because two departments don't talk to one another, or at least they don't use common file formats. With regard to the Siglent, it's almost exactly the opposite. I have been unable to complete on the Rigol. I was able, however, to generate an arbitrary waveform using the Rigol software and download it to the generator, the DG1022. With Rigol, I could not generate a waveform in Easy Wave and download it to the generator. I was, however, able to transfer a wave from the oscilloscope to the generator, and I was able to load an arbitrary waveform that had been generated by Ultrawave, which is the Rigol software. If it's put in CSV format, I was able to transfer that, but the process is somewhat cumbersome. I have to first transfer it to the Rigol generator, generate the signal, capture it on the Siglent oscilloscope, save the waveform, and then download that waveform into the Siglent generator. Well, a lot of information here. I was mainly interested in looking at the connectivity of these devices, and I think that I have satisfied myself that there are connectivity issues in both cases, which I had heard were true. But I hope that the video has been helpful to you in deciding whether and to what extent any of these devices might be useful to you, and if you run into the same problems I ran into, you can at least be aware that you're not alone. It apparently is a common and widespread problem. So I'm going to conclude at this point the review of the two arbitrary waveform generators and their respective oscilloscopes. I hope this has been useful or at least entertaining for you. If so, perhaps you'll look for some more of these in the future. But at this point, I think I'm going to call this the end of part 3, and that part 3 being the end of the comparison.